Rhinoviruses typically cause common colds. In a test of the effectiveness of echinacea, 40 of the 45 subjects treated with echinacea developed rhinovirus infections. In a placebo group, 88 of the 103 subjects developed rhinovirus infections. Test the claim that echinacea treatment has an effect. So, we're going to be taking all this information up here, and we're going to test the claim that echinacea has an effect. So first off, let's get the information out of the problem up here. In the first group, we have those that were treated with echinacea. So we have 40 of 45 developed rhinovirus infections. So our x1 here is going to be 40, and n1 is going to be the total number of people in the first group, which is 45. In the second group, the placebo group, 88 developed a rhinovirus infection. So x2 is going to be 88, and n2 is going to be the total number of people in that group, which is 103. Now here we do not have our significance level. Since it's not given to us, we say that the significance level here, our alpha value, is going to be 0.05. So if it's not given to you, you default to 0.05. Now we're going to write in our hypothesis. So we have our null, and we have our alternate hypothesis. Again, this is a proportion in one group here and a second group here, so two proportions. So we're going to say that the first proportion is going to be equal to the second, as we always do for the null, but the alternative is going to come from the claim. Well, the claim is that the treatment has an effect. Well, either it has an effect or it doesn't. So since the first one is equal to, we're going to say that the second one, P1, is not equal to P2, or group 2. Now that we have all this information, we're going to plug it into the calculator and do our test. So here's our calculator. And since we're dealing with two proportions, we're going to go to Stat, Tests, and 2prop z-test, two proportion tests. And we're going to key in our information, which is just going to be as we have written over here. So 40, 45, 88, and 103. And then we go to our alternate hypothesis, the not equal to decide whether we use one of these three. And since it's not equal to, we keep it as not equal to. And then go down to calculate, hit enter, and we're going to get all our information, but the only ones we really need are Z, our test statistic, and P here, which is 0.51 or 0.5720. So our t-stat is going to be Z equals to 2 decimal places, 0.57. And I'm just going to move the calculator out of the way. And then our p-value is going to be to 4 decimal places, 0.5720. And again, I'm going to use the p-value method to test whether we reject or fail to reject. So it's p compared to alpha, so 0.5720, and it is definitely greater than, make that a little bit better, greater than 0.05. So p is greater than alpha. Since the p is high, we fail to reject the null hypothesis. Now, we have failed to reject it, but we still need to actually state it in a sentence or so of what we mean by that. So I'm just going to go up here and just type in what I mean. So, because we failed to reject, that means we have insufficient evidence. So we could say that there is insufficient evidence to support the claim that the echinacea treatment has an effect. And there we go. And it makes sense. We failed to reject the null hypothesis, so that means that the treatment groups are equal. So people who got treated and people who did not get treated are essentially equal, like the null hypothesis says. So there is insufficient evidence to support it that there is an effect. Now, what if we wanted to do a confidence interval? Same thing. We're going to use our calculator. So bring up our calculator again. And most of the information is already there, so I'm just going to go back to stat, tests, and we did 2 prop z tests. So now we're going to go to 2 prop z int for interval, so 2 proportion interval. And all the information is already there, but if it's not, just type it in again. And it's 95% confidence interval, so we say 0.95. And then we just go down to calculate. And there we have our interval from negative 0.0798 to 0.14885. And we'll just round that up to 4 decimal places for this one. So we're going to say that the interval is negative 0.0798 and rounding to 4 decimal places, 0.1489. Now that we have this, we still need to kind of state what's going on with the interval. So we can just go back here and just drop the calculator. And we're just going to type in what we get from the interval. Now you can tell from the interval we have a negative number and we have a positive number, negative to positive. So somewhere as we're going along this interval, we're going to hit 0. And you need to know that when it comes to these intervals, p hat 1 minus p hat 2 is how we get this. Now the only way to get 0 is if the first group, the first proportion, is equal to the second proportion. It's the only way to get 0. So we can say that since the interval contains 0, it shows that there is no difference in the treatment's effectiveness. Because the treatment effectiveness, if they're the same, when we subtract them, we would get 0. So since it contains 0, there's essentially no difference. And since we said up here that there is nothing to support that there is a difference and that there is no difference here, we're essentially saying the same thing. This claim says that there is not enough evidence to support it that there's a difference. And the interval here is saying, because it contains 0, that there is no difference. And finally, we're going to use the results above to answer this question. Does echinacea appear to have any effects on the infection rate? Again, simplest is easiest. Does echinacea appear to have an effect on the infection rate? We can say that no. Echinacea has no effect on, got an extra F in there, no effect on the infection rate. Again, simplest is easiest. Does it appear to have an effect? No. Echinacea has no effect on the infection rate. And there we go.